So, Ty, what if the next big leap in manufacturing isn't a new machine, but it's a new way of understanding everything that the machine is already telling us?
Because that's really what industrial IoT is becoming, John. It's not just sensors, not just dashboards. We're talking about factories that can sense, interpret, predict, and increasingly act.
Yeah, and that's a huge shift, right, Ty? So, for years, manufacturing data has lived in silos, machines here, maintenance over there, quality somewhere else. And the business systems, they're off in a completely different world entirely, Ty.
Exactly. And now the game's changing. So more manufacturers are connecting product lines, for instance, equipment, energy systems, and external devices, and then trying to turn that flood of data into actual operational intelligence.
Yeah, no. So, okay, Ty, in this episode, we're going to deep dive into industrial IoT in manufacturing, how it's widely being utilized at the moment, and what Microsoft is doing in this space. How does Fabric change the data picture? Where is Agentic AI, and could that really become that real difference maker in the industry?
And we're also going to get into some of the use cases that actually matter to you guys out there. So think reducing downtime, improving quality, saving energy, and helping factories make faster but smarter decisions.
Right, cool, Ty. Let's get started. Okay, so big picture, industrial IoT is no longer just a pilot project or a thing that's going on in the corner of some manufacturing facility, Ty.
Yeah, so according to Deloitte in 2025 Smart Manufacturing Survey, 46% of manufacturers report using industrial IoT already. And the same survey actually shows 57% using cloud, 57% using data analytics, and 54% saying they already have a data standard or a unified data model in place.
Yeah, and I guess that's quite important, Ty, because it's going to be telling us that smart manufacturing is not some futuristic concept anymore. It's already embedded in a large chunk of the industry today.
Yeah, that's correct. It's not just a trend, it's actually moving forward. By the way, Deloitte also found that 27% of organizations plan to invest in industrial IoT over the next 12 to 24 months, while around 30% are planning to invest more in cloud and roughly the same again in IoT, so an AI investment. So it is moving forward.
Yeah, I guess those signals are pretty clear from what we're seeing. So manufacturers are kind of past that point of saying, should we connect machines? And the real question now is, how do we make that data useful, Ty, right?
And that's absolutely the key because let's be brutally honest, um, collecting data is easy. Anybody can do it, but it's actually comparing and turning that data into better decisions that counts.
Yeah, 100% agree. And maybe we'll just dig into a little bit of that now. So, Ty, when we say industrial IoT, we're talking about data coming from lots of different places.
Absolutely, yes. So think production machinery, PLCs, SCADA systems, CNC equipment, robotics, sensors, the whole shebang, including cameras and energy meters, whatever you can think of, and even external signals such as weather, for instance, or supply chain disruption.
Yeah, and that's really interesting, right? And I guess the interesting part of that is none of that data is really especially valuable in and of its own, right?
Yeah, correct. So think of a temperature reading by itself. Well, it's just a temperature reading. But if you can connect it to a machine state, for instance, a machine maintenance history, maybe a product batch or operator shift and quality outcomes, now we're starting to use it in a better way and actually get better usage.
And I guess it's that context is what we're going to be talking about is where the real opportunity is for manufacturing today.
Absolutely, that's the key word, context. You can really start answering questions like, for instance, why did line two slow down, or why is my scrap raising on this particular shift, or which machine is most likely to fail over the next week or month, which site is wasting, I don't know, more energy, per goods per unit produced, and so on and so forth.
And they're really kind of business valuable questions, Ty, right? They're not just technical questions with some technical response. They're things that we can actually bring back into the business to make decisions on, right?
100%. So the question is really, and this very clean and open, where do Microsoft fit into all this?
Yeah, well, maybe I can pick up a little bit there, Ty. So, look, Microsoft's industrial story is now much broader than just let's get a device connected to the cloud, right? Okay. I mean, tell us a little bit about IoT operations, Ty. I know you've got a bit of info about that.
Yeah, so that's basically the first piece of Azure IoT operations around the connectivity and connecting devices into our cloud. So, which it's basically built on industrial connectivity scenarios and edge scenarios. So it's that matters for factories, that don't run clean or cloud native environments. They can run in a hybrid state, hybrid systems with IoT constraints, legacy equipment. Let's be brutally honest, there's an awful lot of legacy out there, and some machinery might be from the 80s, 70s, and so forth. And it makes it a lot more, and it makes it a lot more operational complex.
Yeah, I understand what you mean. And I guess the other thing there is that a lot of those machines have got proprietary data flows. So it's just about being able to connect those up via an edge device to do something with, right? And I guess that's the other point where, from a Microsoft perspective, where Azure Arc becomes important because Arc can really help bring that consistency across all those different systems you've just mentioned. So edge, hybrid, if there are existing cloud resources, which is kind of a big deal when you're trying to manage lots of different plant and different distributed sites and all that kind of stuff, Ty, right?
Absolutely. And then you've got things like Azure IoT Hub, which plays a major part in, the maturity of device connectivity and the backbone. So it's basically the foundation for ingesting and routing device data. Simple.
Yeah, no, absolutely. And other things, Azure Digital Twins,
Mm.
these are really useful when you kind of want to model those assets and any relationships between those assets, what lines they're on, what facilities they're in, because manufacturing is never just about one machine. It's about that system around that machine as well that we can model with digital twins, Ty.
Yeah, and John, don't forget Defender for IoT. And when we start connecting all these industrial systems together, we need to have in forefront of mind that security is going to be absolutely critical and central to this.
Yeah, exactly. Smart manufacturing without OT security is just risky manufacturing with better dashboards, I guess, Ty.
Yeah, 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 very good. But John, listen, let's start getting this a little bit more interesting for his viewers. Why does fabric matter, and where does that play a part?
Yeah, and I guess the hard part in manufacturing around that is not just can we collect the data. I think we've already said that that's relatively straightforward, but how do we unify it and bring all of that data together into a single platform, a single plane that we can do something with, right?
Yes, I suppose that's one of the major pieces of the puzzle, do you think?
Yeah, exactly. That's where Fabric kind of plays the game. It's given us that platform where industrial telemetry can sit alongside that enterprise data from ERP, finance, maintenance quality, all these different things coming into the system. It can all sit in that unified platform together, and that's where we can do some magic.
So what we're actually saying for his users out there in plain English, the plant data is historically in one system, maintenance data in another, ERP data somewhere else, and actually, you might have got spreadsheets bridging different gaps and so on and so forth. But what you're getting to, or where we're trying to get to, is a unified analytics and data foundation.
Yeah, 100%. And I guess that's where we can start breaking down some of the components of what Fabric offers. One Lake, that big one single unified storage location that we can put all of our data into. Certainly for machine readable information, real time intelligence or RTI built into Fabric is taking all of that time series data that's flowing from these machines and actually storing it, but we can query that in real time. We can inference and overlay AI capabilities in real time and do some great things. Again, event stream. When something happens, there's a temperature sensor on a machine that raises above a certain a point that kind of indicates that something's going wrong. We can start using event stream for things like predictive maintenance. And then, kind of how do we query all this data just if we were an analyst on the edge in Fabric? KQL, custom query language, they're really relevant here because, with industrial IoT, it's all about that streaming data, that event data, like I say, all of that time series behavior. Marry that up with your ERP data and other system data within that Fabric layer. Like I say, that's where you can start really inferencing and putting that context and drawing out those really valuable business insights.
So John, what I'm hearing there in a nutshell is that we can ingest live machine data and signals. We can correlate it to a different or some type of business event, and then start to build context on a complete picture of what's actually happening on the shop floor.
100%. That's the unlock tie, because once the data's together, you can stop asking all those different isolated questions and start really drilling into those connected ones.
So I suppose then what we're actually saying is the big change is that the factory is now not just going to be that black box, what we can't see into.
Yeah, exactly. I mean, it's all about bringing those operational technology data feeds into your information technology data feeds and bringing the shop floor into the boardroom, right? So we can connect and cause and effect across all of these different systems.
All right, so let me give an example of that. So I'm thinking when sometimes we might have a quality issue, it might not actually be a quality issue. It could be a maintenance issue or an energy issue or a raw material issue or maybe a shift pattern problem or change.
Yeah, or maybe a production bottleneck might not be caused by the machine at all. It might be a supplier delay or a downstream scheduling conflict. Sometimes we just don't know because these systems are so disparate, right?
So for us viewers out there, that's why Fabric is so important to this solution. It's not just the data store for industrial data. It's a way to turn fragmented operational signals and data actually into usable intelligence and knowledge.
Exactly. And once you've got that usable intelligence and knowledge, you can then build your dashboards, you can create your alerts, you can build your models, and eventually AI agents that can work across that full operational picture tile. You can understand the power there, right?
Absolutely. So let's have a think now. Where does agentic come into this? And do we need to start thinking people are going to get axed? And where should we be careful, John?
Yeah, absolutely. Let's dig into that a bit, Ty. So because agentic AI is really powerful, but really only when it's grounded in that real data and proper guardrails, right? That's the message we're always hearing. Yeah.
So let's define it a little bit more simply then. So in manufacturing, agentic AI is not just a chatbot answering questions about your plant, yeah?
Yeah, it doesn't need to be. So, it's a layer that can detect signals. It can reason across data sets. It can recommend any actions or trigger specific workflows and coordinate all those responses together, all within that kind of business defined context and constraints system.
All right, cool. So really what we're saying is that agents can monitor live machinery telemetry and maybe notice abnormal vibration patterns or check maintenance history, look up spare part inventory and so on and so forth, and then suggest when would be the appropriate and best time to maybe do a maintenance window, yeah?
Yeah, exactly that, Ty. I guess on that point alone, it could be the fact that when a machinery part breaks down, it might have a production batch going through the machine at the time that then has to be stopped and recalibrated or restarted. Whereas if we can do a bit of that predictive maintenance or proactive maintenance, all of a sudden, you can start to see how this can save time, save waste, and certainly, allow for a higher production throughput. But saying that, maybe it's a quality problem. Maybe there's some quality drift. So correlate that with that material batch change and maybe a shift change, and then create a root cause summary for the operations team so they've got all of the information available to them when they're trying to figure out what's gone wrong.
That sounds amazing. And actually, I'd be surprised if most industries and organizations don't want to do that.
Mm.
They should definitely be doing that. Now, obviously, the big thing at the minute around the world is energy consumption, and energy prices. So I'm assuming that, and keep me honest, that agents maybe can look for energy consumption spikes, look at low value production windows, and then maybe recommend shifting workloads or maybe powering down equipment. What do you think, John?
Yeah, you've said it, Ty. That is the exact difference between doing that analytics and then actually performing some action. Yeah, so that's the real key there that you just mentioned, Ty.
So really, that's why agentic AI must be so compelling within manufacturing. Yeah, it can sit on top of an industrial stack, data stack that is, and help teams on the shop floor in IT, in OT, to move from reactive, what happened, to what should we do next, and this is how we're going to become more proactive.
Yeah,
So,
exactly, exactly.
so John, why don't we have a look maybe at some use cases?
Yeah, go for it. What have you got top of your list, Ty?
Okay, so I'm thinking maybe, and we sort of covered this a little bit, predictive maintenance that becomes coordinated maintenance. So, we're not just thinking this motor or part may fail soon, but this motor is degrading, it's having less performance through it. We've got a spare part available. The line has lower demand during this time window, maybe tomorrow afternoon or next week or whenever it is, and the recommendation is to change it. Yeah, so that's one idea. What do you think?
Yeah, no, massive, huge step from just having very simple alerts, right, Ty?
100%. I mean, there's things like quality issues, root cause analysis. So, enabling agents to combine machine settings, operator data, I don't know, environmental readings and inspection results to be able to explain why raw scrap materials has increased.
That was what mentioned earlier on. It's going to mean that kind of faster time to correction, meaning less waste, less finger pointing, right, Ty?
Yeah, absolutely. So John, why don't you give me an example maybe around energy optimization?
Yeah, yeah, sure. So, I mean, look, factories, like you mentioned earlier, Ty, they're really under pressure to reduce cost and emissions. An agent could identify where energy is being wasted or which machines are kind of running on idle a lot and which production schedules are driving that unnecessary consumption, right, Ty? That kind of use case is the thing that's going to get the finance team and the sustainability team in the same room together, right? Ty, what do you think?
Absolutely. Absolutely right. Okay, why don't you give me one around maybe production recovery after a major disruption or some type of disruption?
Yeah, look, like a supplier delay, machine failure, or maybe a staffing issue. It doesn't just cause a local problem, that's going to ripple across the plant. So, that if we could overlay an agent to help recalculate that kind of production plan, maybe flag those downstream impacts and recommend some least disruptive recovery path, that would be a really interesting way forward. Ty, jump into one. I've seen there's some interesting ways that we can put for frontline workers using Copilot to consume some of this. What do you think?
Absolutely, yeah. I mean, think around it. Plant manager co-pilot. Imagine, a plant manager asking, why was a particular piece of kit down yesterday? And getting an answer that combines maybe telemetry, maintenance, labor, quality, schedule data, and you know what? That then becomes the difference between just having a dashboard and you trying to understand it, and having a co-pilot assistant who can help you define and move forward and make the appropriate decisions. So co-pilot absolutely should be part of this conversation. But John, one last one. Then I want to move on from this. So talk to us around maybe supplier safety and compliance.
Yeah, another great area, Ty. So, using agents to help spot those unsafe operating patterns. Maybe there are some overdue maintenance risks across all the machinery, or maybe there's some deviations from, expected process condition within a particular batch or something along those lines. It's not there to replace humans, but really humans are there to catch these problems earlier and be aware of all these problems. So it's going to be a really compelling event. Ty, let's branch into a bit of a different area then. Why do you think this is going to matter for businesses out there?
Yeah, so if we think of it from a business perspective, it all comes down to basically a few outcomes. All right. So one, less downtime. Two, better throughput. And three, less wastage. Four, better energy. And then, if we think around the organization's resilience and the ability to pivot and change, it all becomes accelerated. And then, maybe most importantly, they have a better way to scale manufacturing because of the knowledge, what they've getting across multiple sites, across different regions, or maybe around the globe. So, let's think around it. One of the biggest problems in manufacturing is that um, there's a need to unlock individual data and individual plants and individual teams so that they can become experts on their own right and understand local uh, microclimates, microeconomics, or things that's going to have impact to that particular area. What do you think about
Yeah.
that, John?
No, 100%. I agree, Ty. It's, it's unbounded kind of opportunity, I think, is where a lot of big businesses are going to see this. And, and maybe even differentiators. One of the things I speak to customers about a lot is really how to unlock maybe other areas of the business from their IP data, if it's from plant or machinery, and they're combining it with systems and processes that live outside, or, as we mentioned earlier, external data feeds that are coming into that. It just unlocks an unbounded kind of way of working, and I guess if you can encode more of that knowledge into your data platform and those AI workflows, you're going to really reduce that the dependence on heroics and those individuals that kind of make the whole operation known, and we're able to make the operational activities more repeatable in that sense. That's where I think the value seriously gets stacked against each other.
100%. So let's do a little bit of a reality check though, John. And we need to make sure we're keeping everybody grounded. So let's first of all be very clear. None of this is automatic. Do you agree?
Yeah, absolutely. I think if we start from the sense of, look, industrial IoT, it's not going to be creating that value by itself. You need good data models, you need some good governance, you need that overlay of OT security. There's going to be integration work between data platforms and data from different disparate systems. There's going to be some process design, and kind of flow with how this data comes in and what alerts and mechanisms there are to feed into that process. And of course, change management is going to be a thing as well. So you need to be strong on change management to make sure that you're really seeking out those useful insights for your business. Then we factor in the agentic AI piece. It's not really some magic factory brain. I mean, that's the idea that we get at that point, but it's only going to work when it's fed reliable data and it's constrained by real operational rules. Yeah. So the winning approach is not let's let AI run our factory completely. It's let's let AI help the factory think faster, maybe see more clearly and respond a little bit more intelligently than. And I think that's grounding everything that we've been talking about over the last few minutes there, Ty.
100%. So, guys who's watching and girls, the big takeaway in this is that manufacturing is shifting from connected machinery to connected intelligence. Industrial IoT brings the signals in. Microsoft Fabric helps unify that, and then the agentic AI can turn it into actions. So that's the next stage of smart manufacturing. Think about it, not just data collection, but data coordination. John,
Yeah, no, absolutely. Yeah, couldn't agree more, Ty. And look, thank you everybody for watching. Please do let us know your thoughts of this episode below. Me and Ty, I'm sure we'd love to jump into any other specific discussions around other angles if people would find them of use. Things like predictive maintenance, or maybe there's some smart factory architecture that we can kind of help surface via Microsoft. Or even if it's some more deep agentic AI elements around manufacturing specifically. Happy to try and look at to jump into that one of those areas. But look, for now, drop a comment, let us know your thoughts and feelings about this. And if it's helped, as always, like and subscribe and share it with the person in your team who still thinks the machine data is just for the engineers. Ty, I think we're done.
We are. Thanks for watching, everybody. See you next time. Thank
Thanks
you.
all. Bye.